2 tests using cargo to ensure everything goes as planned once the astronauts are ready to make their journey. The first cycler vehicle, Cycler A, will carry 6 astronauts to Phobos. These astronauts will be in charge of surface operations on Mars while we construct the colony. The second cycler vehicle, Cycler B, will come 1 synodic period later, and it will carry 18 astronauts. 6 of these will go to replace the crew on Phobos. The other 12 will go to the surface of Mars and join the crew of 6 from Phobos. These will be the first men and women to ever set foot on another planet. From there, 18 astronauts will continue to come on each cycle.
In order to meet the 280 kilowatt power demand, we will employ 2 ATK solar panels.
Around Mars, the solar flux available is only 40% of the solar flux available around the Earth. These solar panels are circular and flexible. This design allows them to be very lightweight and to have very few storage volume.
These flexible wings are 28 meters in diameter and are capable of folding up like a Japanese fan in order to fit inside a small fairing for launch.
The first floor of the XM3 it houses the power systems, thermal systems, water systems, and life support systems, all necessary for crew survival. The second floor contains like a lab space and a group habitat space. On the third floor is the habitat's personal space.
The human lander, or hula, is what's going to be the capsule that contains the first 6 crew members on every mission.
Inside the human lander, there'll be 2 rows of 3 seats each. The astronauts leave the cycler and land on either Phobos or Mars. Either of these journeys will take approximately 1.3 days.
Upon leaving the cycler, the human lander will approach Mars in a hyperbolic trajectory, such as this, where we will be performing an aero capture maneuver where we skim the atmosphere, and then head out either to Phobos or back around for a direct entry at Mars. To enter Mars, we have a heat shield which is mechanically deployable. We'll be deploying this in space upon leaving the cycler, and this will take the blunt of the heat force and the deceleration maneuvers. Upon descent, this will decelerate us to a reasonable speed, and then we will deploy a balloon in order to decrease the speed even further. The high heating will be absorbed by the heat shield, and the balloon will do a lot of the deceleration in the final descent stage. Upon reaching a reasonable terminal velocity, a propulsion system will be ignited, the heat shield will be dropped, and the balloon will be cut. The terminal propulsion system will bring us down to a 0 vertical velocity and cause a hover maneuver where we can move laterally if need be to increase the accuracy of landing. We will deploy landing gear and finally land directly on the Martian surface.
On the Martian surface, the human lander will transform into a rover. The crane will pick up the human lander and place it onto the chassis. The human lander will then be able to travel up to 20 kilometers per hour and go up an incline of approximately 30 degrees.
The main value of the Phobos base is that we're being able to eliminate the 24-minute time delay that can happen between Earth and Mars.
The Phobos base will be composed of 3 XM3s and 2 human landers. This will be the home to the crew of 6.
Back on the surface of Mars, the main colony is made up of 9 connected XM3 modules. 3 in the center as the crew living quarters, 2 additional on the outside to serve as water processing storage, 2 other out here to serve as farming, and then 1 extra core module and another module to serve as the medical bay. Together, these modules form the entirety of the colony and will house at most a 54-person crew.
Even if it were possible for the colonists on Mars and Phobos to be able to produce 100% of their food, water, oxygen, and nitrogen, there are just some things that cannot be produced on these bodies. That's where the cargo lander, or Carla, comes in. Carla is the primary